let's have P and Q. So P and Q represents any propositions, and we have true, true, false, false, true, false, true, false. The first one is we have P and Q. So this is the symbol, and we have this is and, this is conjunction. So in conjunction, if all of the proposition is true, then the result is true. So we have true, true, true. So di man siya true, so tanan, so it's false, false, false. Okay, is P or Q. So this is or, and it's disjunction. So this disjunction of two propositions is false only if each proposition is false. So we have true, so we have true, 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 false, true. Basta naa lang kay true, true na true, false, false, so this is false. Okay, so that is disjunction. The next one is we have negation. So for negation, we have not P. So it is the reverse or the opposite. So this is not, and this is what we call negation. So not P, so true, false, true. So this is false, false, true, false, true. The next one is conditional. So conditional is if P, then Q. So this is if, then, and this is what we call conditional. Okay, so the proposition if P then Q is false only when the P is true and the Q is false. Otherwise, if P then Q is true. So we have here true, true, so it's true. True, false, so this is false. This is the only event where conditional is false, when P is true and your Q is false. And then we have here false, true, that is true. False, false, that is true. Now, what if in the case of Q, then P? What will happen if it's Q, then P? So it's the reverse. It's true, true, so it's true. False, true, this is true. True, false, so it becomes false because your Q here is true and your P is false, and this is the only event where the conditional is false. And then you have the last one, false, false, it's true. The position matters. The next one is what we call biconditional. That is if P, that is P, if and only if Q, that is like this, if and only if. So this is biconditional. Okay. For biconditional, if P and Q are true or both false, then the proposition is true. If P and Q have opposite truth value, then this is false. So in this case, we have true, true, same. So true, true, false, so it's opposite, so it becomes false. False, true, it is false. False, false, it is true. So that is biconditional. The last one is the exclusive or. So P exclusive or Q. So this is exclusive or. If P and Q are true or both false, then P exclusive or is false. If P and Q have opposite truth value, then it is true. So we have here true, true, since same man sila og value, so this is false. It is opposite to biconditional. True, false, opposite, so it's true. False, true, it's opposite, so it's true. False, false, it's the same. So we have false, false, it's the same, so it is false. So this is exclusive OR. This is the summary of our compound proposition. Now let's have our first example in constructing our truth table. So we have here the first one is not P or not Q. So you have P and Q. You have true, true, false, false, true, false, true, false. And then first is your not P. So we need to have this, then not Q, and then the whole. So we have the not P, so it's the opposite of our P. So true, this is false, true, false, false, true, false, true. Next is your not Q. It's the opposite of our Q. So true is the negation. So false, false, true, true, false, false, true. And then we have the whole thing or the whole given, not P or not Q. So we have our not P and not Q. This or is if na lang kay true, true na. Otherwise it is false. So false, false. So this is false. Kay wala man true. False, true. We have true here. So this is true. True, false. We have true. So this is true. True, true. Obviously this is true. So this is our answer for number 1. Next is number 2. Number 2 example. If we have P, if P, P, if and only if. If P, then P, if and only if, not Q. Okay. So meaning we need to have this first, the not Q, and then the P, if and only if, not Q, then the whole thing. So we have here P and the Q propositions. We have true, true, false, false, true, false, true, false. We have not Q, false, true, false, true. Then we have P, if and only if, not Q. So we have here our P and not Q. Now this if and only if is biconditional, meaning if it's the same, it's true, and if it's opposite, it's false. So true, false, it's opposite. True, false, it's opposite, so it's false. True, true, it's the same, so it's true. False, false, it's the same, so it's true. False, true, it's opposite, so it's false. The next one is the whole given. If P, then P, if and only if, not Q. So you have your P here and this one. So this is conditional. Now in the conditional, if then, it is only false when your P is true and your Q is false. So we have here true, false, true, false. So that is false. That's the only case where we have false under conditional. So true, true. So this is true. False, true. So this is true. And false, false. This is true. So this is the answer for number 2 or example number 2. For our third example, let's have not P or Q, exclusive or if P, then Q. We need to operate this first and then this second. This is the third and then the last one. So just remember your GEMDAS or PEMDAS rule. You have to evaluate first what is inside the parenthesis. So let's have PQ. P is true, true, false, false, true, false, true, false. Let's have not P, the opposite of P. True, this is false. True, this is false. False, the opposite. True, false, the opposite. True. Next is not P or Q. Okay. Now, kanus ato mag-true ang or? Okay, very good. If you have at least one true. So, you have not P, and your Q. So, true, false, this is true. False, false, false. True, true, it's true. False, true, it's true. Okay. Next is your P. If P, then Q. So you have here your P, then your Q. So remember, the only event that this will be false when P is true and your Q is false. So you have true, true, it's true. True, false, this is false. False, true, this is true. False, false, it's true. Okay, and then our last one is the whole given. So you have not P or Q, exclusive or if P, then Q. So you have this one and this, and you use exclusive or. Do you still remember exclusive or? Okay, very good. Meaning, if it's the same, it's false. And if it's unlike, it's true. So let's have true, true, the same. So it's false. False, false, the same. It's false. True, true, the same. It's false. True, true, it's the same. It's false. Okay, so this is the answer for our third example problem. I think you are ready now. You can now construct your own truth table. So I'll give you some exercise. So you answer this one, and then you may comment down below your answer. You have here, if P not Q, and then this is an and symbol, that is conjunction. You have if P, then not Q. Okay, so you have number 4, your practice. Your number 3, your example number 3, example number 2, example number 1, and you have your summary. That's all for truth table. Feel free to ask questions, and see you in our next video discussion.